All right, so we wanted to walk through these balancing equations for you so you can see how I did it. Hopefully that kind of helped reinforce what you're thinking or see where you went wrong on what you were doing or what you weren't quite grasping. So the key to this is where the arrow is divides the reactants from the products. Reactants come together to react. The reaction occurs in the arrow. So the arrow represents the actual reaction occurring. Nothing's happening here. This is before. Nothing's happening here. This is after. This is where everything is happening at the arrow. The law of conservation of mass says there must be the same amount before the reaction occurs as there is after the reaction occurs. Now, it might change form. It might turn into something different, right? But the matter has to be the same, okay? So to do that, just to kind of, we have to have equal mass here, equal mass there. Now, how we do this is, say this one here, N2, right? If I need another nitrogen to balance this, I can't just change that to N3 because N3 is completely different than N2. I can't just add a nitrogen in, right? So these are set in stone. We can't change the way these are. That happens here, right? We don't have any control over that. What we can change or what we can make sure happens is that, it's like the mixture. Say you're painting a car. You got to put a certain amount of the paint, a certain amount of the paint thinner and the hardener, right, to a ratio. So you can change that, but you're not changing the chemical reaction that's happening. It don't matter how much of what you have, it's going to happen one way. So to do that, you can only add what is already there. So if I look at both sides, I have one magnesium here. I have 3 magnesiums there, Mg3. This does not balance. Okay, I have 2 nitrogens, 2 nitrogens. This does balance. So what I need more of, since I have 3 magnesiums and 1 here, I need more here, right? So this exists as just Mg, right? So I would add, that would give me 2 Mgs. So if I had this, I added more of what was already there, this will balance me, right? But we don't write this out because it's sloppy. So we just say, okay, I have 1, 2, 3 of these. So I need 3 of these for every one of those, right? That's my ratio. I need 3 of them for every one of those. I need 3 parts paint, 1 part hardener, right? To get 1 part magnesium nitride, right? And you don't have to include the ones. It's just like in math, x is the same thing as 1x. So you wouldn't have to include the ones. But I will on this just to make my point clear. Moving on to the next one. 1 aluminum, 1 aluminum. This is balanced. This is good. We don't have to do anything. 2 chlorines, 3 chlorines. This does not balance, so we must change. I have less chlorines here than I do over there, right? So I need more, okay? I cannot just add 1 chlorine. This does not exist as 1 chlorine. That exists as 2 chlorines. So I must add 1 Cl2. Does that make sense? So now I still have 1 and 1, but now I have 4 and 3. So now I need more over here. So again, I can't just add a chlorine to it. I can't do that. This exists as AlCl3. I can only add AlCl3, aluminum chloride. So my only option is to add AlCl3. That's it. That's my only move. Well, now I have 2 aluminums. Yep, so I need more aluminums over here. This is just aluminum, so I can just add 1 aluminum. Still have 4 and 6. So now I'm back to needing more chlorines here. This will be Cl2. Now I have 2, 4, 6, 6, 2, 2. All right, so my final answer to this would be, well, I needed 2 of these. I needed 3 of these. And I needed 2 of these. Now there are equal amounts of aluminum and chlorine on both sides of my reactants and products. I didn't change what happened. I didn't change the formulas of what's there. I changed nothing. I just made sure I had enough of each one so that it would work out and be balanced. All right, I'm going to do one more for you, and I'll kind of turn you loose. I know I got 4 written, but I got to go. So I'm going to do one more for you. 2 phosphoruses, 1 phosphorus. 5, 4, or 5, 6, right? And 4, 2, and 3. Just kind of a general rule of thumb, save oxygen, hydrogen for the last. Never start with them unless that's the only thing that doesn't match. So here my phosphoruses did not match, so that's what I'm going to start with there first. So I have 2 phosphoruses over here, I need 2 over there. What I cannot do is just add a phosphorus. Yes, this would balance it, but we are changing chemically what's happening. We can't do that. So I have to add the whole thing. That is phosphoric acid, by the way. Starts with H. So now I have 2 phosphoruses, 2 phosphoruses. That's good, right? That balances. I have 6 hydrogens and 8 oxygens. Over here I have 2 hydrogens and 6 oxygens. So see how there's oxygen here and here? That's going to make it more difficult to balance. So I'm going to do the hydrogen because this is going to be easier for me to turn this into 6. So if I add another one of these, now I have 4. If I add another one, now I have 6. So that gives me my 6 hydrogens. 6 hydrogens, 6 hydrogens. 2 phosphoruses, 2 phosphoruses. 8 oxygens, 5, 6, 7, 8. So that balanced out my oxygens for me, right? Always save the ones. So if you have like an atom that is in different things on the same side, like oxygens in 2 different compounds, try to put that one to the end. Sometimes it'll take care of itself, or it'll make it more clear at the end what you got to do to balance it. But if you were to start trying to balance the hot oxygens first, you'd find yourself in a mess real fast, possibly. So my final answer is, I just needed one of these. I need 1, 2, 3 waters, and I need 2 phosphoric acids. So this could be taught several different ways. Some people say, take your coefficient, 3 times 2 is 6, 2 times 3 is 6, 2 times 1 is aluminum, like you distribute it like you would in math, so if you had this in math, you would go 2x plus 2. This is probably the most common way to do it. 3 times 2 is 6, 3 times 1 is 3. To kind of figure out your numbers quickly. Yes, that works. Yes, that's great, but I don't think it gives you that full, clear picture. Whereas if we are actually adding compounds in their entirety, right, as we go, I just think it makes it easier and it builds that foundation a lot better than just trying to use number tricks and stuff like that to get it done. Hope this helps. If it doesn't help, let me know. I'll figure out another way to explain it to you.